Hello and welcome to our first narrated SolderCore video. In this video we're going to look at demonstrating how we can log data to the onboard microSD using Core Basic. Before we get into the software, I'm just going to go through the hardware configuration. We've got three Arduino shaped boards, or Arduino shaped ish boards, a couple of sensors, and all held together with what we call the flat 4 or the 2x2. The flat 4 is down here. It's this, it can just hold four shields together, and they're all connected up so they can talk to one another. Down here is the main SolderCore board. I'd like to just say that this isn't a production version. This is mine that's been hand assembled from quite a long time ago. On this board we've got obviously the Arduino headers. What's unique to the SolderCore is, or what makes it different from the Arduino, is that we have a microSD card holder. Currently you can see there's a microSD card plugged in. Over here we have the micro AB connector, which at the moment is just powering the device. There's no USB traffic going across into the SolderCore. We have the RJ45 with integrated magnetics. And the Ethernet cable here going off to the router. This is the main way in which you write your code and interface into the SolderCore. We have a standard 2.2mm barrel jack, and the micro itself and all the peripheral bits that make it all work. We've got connected to the SolderCore a SenseCore, which is just a convenient means really to connect the various SenseCore products that we have. On this particular board, all we have are two sensors. So we've got the Core Lights, which is an ambient light measurement device, which is I2C, and we've also got Core Temp, which is an SPI device, and as the name would suggest, it measures ambient temperature. The chip select for all SPI devices by default is done by the bus expander, which you can kind of see, you might not be able to see, but it's in the middle of this board. The SolderCore communicates with the bus expander over I2C and selects the chip select for you. This is all hidden away, and all you have to do is install the driver to make it happen. It's relatively straightforward, as we'll see in a minute. Over in this corner, again, we've got another pre-production module, which we call the breakout module. This serves two purposes. One is to make it really easy to wire into your SolderCore devices through the screw terminals, but also we've added I/O state LEDs. So we've got two LEDs per I/O pin. Depending whether the red LED is lit or the green LED is lit, you can determine the state of the I/O pin. As you can see, most of the pins are all low, apart from these two. These two happen to be the I2C lines, which are pulled high by the SenseCore. So that's kind of what I'd expect in this scenario. Now that we've done a brief tour of the hardware, we'll get straight onto the software, and I'll demonstrate how you get in and edit the code. So now we've gone through the hardware, it's time to look at the interesting bit, which is programming the SolderCore. As mentioned previously, we program the SolderCore using the Ethernet interface. So to get started then, you need to telnet in. I'm going to use the telnet tool that comes loaded with Windows 7, which you have to activate. That's discussed in the documentation found at the SolderCore website. So to get going, type in telnet space core and then your serial number. You'll find the serial number on the underside of your board on a little sticker. This is a pre-production SolderCore, so I'm just going to type in 6Fs. And push return, and from there you're taken straight into the SolderCore front end. As you can see, I'm on version 0.99, which is probably going to be an earlier release than the one that you're going to be running. So this project's all about logging data to the microSD card. So how do we look at the microSD card? Well, it's just like DOS typing dir, and we can see all the programs and files that exist. Core Basic programs end in the extension .bas. As you can see, there's lots of .bas files. And at the bottom, there's two files that we're interested in, which is the log.csv file, which is where we're going to be logging our data to. At the moment, it's got 17 bytes. And a skeleton program called logbasic, which is a kind of a shell of a program which we're going to add to get running. What we'll do is we'll load up the program straight from the microSD card. Just use the load keyword, C is the micro SD, and then just type in log basic, like so. Push return. To view the program, I'll just clear the screen first. To view the program, type list. And there you go, we've got a simple program starting at 10, ending at 310. It hasn't been renumbered yet. And what we've got there, line 10 is just a comment. Line 110, we've got a call to log USD or log micro SD, which is a call to this procedure down here. And this is the procedure that opens a file and then writes three variables: my time, my val1, and my val2 to the file. So there's a couple of ways of editing this program. You can type in edit the line number. So if you do edit line 10, we can edit the comment. We'll just add a full stop, shall we? And then we'll list it again. And there we have, you can see the full stop that's been edited. The other way of editing, which is a bit more convenient, is just to type edit, and we get into the full screen editor. Now you can use the arrow keys on your keyboard to navigate your way around, and you can add lines and so forth, and do as you will. We'll add now. It's a quick way of saving your programs is just to hit the F2 button, which I'll do now as we've changed it by adding the full stop. As you can see there, it says saved. Log bash to the C device, which is the micro SD card. Okay, so we want to log data to the micro SD. The data is going to be coming from the two sensors that we saw earlier, core temp and core light. So I need to show you quickly how to access the data that these things provide. Core Basic uses drivers really to access any external hardware. So you install devices, whether it's an LCD shield, a sensor, or whatever. You need to install it before using it. So just to get started, we'll install the core light module. So what you need to do is type install, and then in quote marks the name of the module you want to install, which in this case is core light. We're going to install it as CL, which is nice and easy. For the temperature sensor, it's a little bit more complex. Because the temperature sensor is based on SPI, we have a chip select, and the chip select, as mentioned, is actually driven by the bus expander found on the SolderCore. So we actually need to install the SolderCore to do this. So if we do install SolderCore, so SolderCore dash SolderCore as SC. And then we're going to use SC, the SolderCore, to provide the chip select. So install temperature sensor. The TC77 is the chip in which this temperature sensor is based on. We're going to install that as. Oops, so we've got to use using SC, and it's in position A, I believe. So using SolderCore A as TS, which I'm just going to save that by hitting F2. So we've installed the 3 units that we're going to use. So we need to call the various methods on these devices and get some data for them. What we'll probably do is, if I set up a simple loop to read the data 10 times, we can see if it works. So to set up a loop, we can just say for I equals 0 to 9. And you can see it auto indents. I'll just put next I here. Next I. Okay, so to read the temperature sensor, we want a temperature variable. So A ambient temperature equals temperature sensor dot to access the temp, and that's it. So once that line's executed, temperature as read by the temperature sensor device will be assigned to the variable AT, and we'll do the same for the ambient light. So AL equals core light dot light. That's it. And that's all you need to do. The I2C protocol is all taken care of by Core Basic. So we'd probably like to see that. So if we just do print temperature temp equals I'll just rem this out for a second. Okay, so what we should find is that when we execute this program, we loop round in this loop here 10 times, 0 to 9. We read the hardware temperature sensor, and we also read the light level from core light. If there are any errors in this program, we'll get told pretty quick. Once this program gets passed or is iterated 9 or 10 times around the loop, which we need to apply there. I have to put an end here to stop it trying to fall into deck proc. Okay, so at the moment this procedure isn't going to get called. To exit the editor, hit Control D. We'll clear the screen. And if we run, if it's all good, we should see the temperature and the light levels printed onto the screen here. Which you do. Brilliant. Excellent. So that's working. Just to prove that is doing something, I'm just going to switch off my light. I'll run it again, and we should see the lux level drop down quite significantly. There you go. It's quite dark. I'm going to switch that back on. Right, let's get back into the editor. I'm just going to save it. Right, so we know that we've successfully picked out the data from the modules. We've printed them to the screen, which is great. Now I'd like to log them to the onboard micro SD card. This is where this procedure comes in here. So as you can see, you've got define proc. So define procedure, it's got a name, log USD or log micro SD. And we're passing in 3 variables, my time, my val 1 and my val 2. And at the comments, here we try and open a file. So we're trying to open the file on the micro SD card called log.csv, and we're going to open it with read-write access. F is like the pointer to the file. If it fails, we'll get a value of less than 0, which is what this check statement does here. So if F is less than 0, then it's failed. Let's return. This ptrf equals extf. We want to make sure we append data to the end of the file. So what we're doing is we're sending the file pointer to the extremities of the file. That's all that line does there. We've commented out a line here, print, so it just prints the values to the screen, which you don't need to do because we're doing it in the loop above. Print hash f is actually going to print data to the file f, which we know at the moment, as described here, is log.csv. Once it does that, once it's completed, it closes f and it returns from the function. Only needs to be called again 9 more times. So to see this in action, we can unrem this line. Okay, and I'm going to save that. That's saved. So I could just run this program now directly from the editor by hitting F5, or we can step through the code using the F10 button, which I'll demonstrate. So if all's good, let's just hit F10 and see what happens. Oh, no, we've got an error there, so let's just correct that. Oh, I've just spotted another one while I'm here. Okay. Right, so let's try that again. Let's hit F10. Brilliant. So you can see there that we've stepped into the code and it's highlighted the line that's just about to be executed with the green bar. So we can continue stepping through it. We've entered the for loop. We've successfully read the temperature and light measurements, print it to the screen, and then we call log micro SD. So we should say jump into this function. We open the file. Hopefully f is greater than 0, so we shouldn't print fail to open file, which is good. We set the file pointer to the extent of the file. Excellent. And now we write a file to the micro SD card, or sorry, write some values to the micro SD card. I'm not going to step through the whole program because it'll take a little while. I'll just hit F5. As you can see there, this is the output, and the program is ended. So that's how you step through the code. What we need to do now is take the micro SD card out of SolderCore into the adapter and into my PC, where we can see if this program has worked. Okay, so I've removed the micro SD card from the SolderCore. I've put it in my SD adapter and it's now plugged into the side of the computer. I've opened it up, and as you can see, we've got all the Core Basic programs that we saw when viewing it from within Core Basic. The file I want to look at is the log CSV. So what I'm hoping is that the data has been logged 10 times to this format. So what we'll do is open up Excel and drag this in and see what we get. Okay, I did previously set these 3 field names up earlier, so that wasn't done programmatically, but what we can see is we have rows 3 to 13, i.e. 10 data points captured. A little bit of fluctuation on the lux level, but the temperature seems fairly solid. So yeah, that was a quick demo of how to log data.